Good morning, good afternoon, and good evening, wherever you are. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
All righty. Hello, we are live. Welcome, everybody. Thank you for joining our webinar about Rocky Linux from CIQ Hardened. Today, we're going to have a conversation with a couple of people that were instrumental in developing and delivering Rocky Linux from CIQ Hardened and are experts around Rocky Linux and Linux security. We're going to learn about why Rocky Linux from CIQ was built, what problems it's looking to solve, and then we're going to double click and understand what exactly was hardened, why that was hardened, and to an extent, how it was done. Before we jump into the meat of it, I just wanted to call out that we will go for about 30 minutes, and about the 30-minute mark, we will stop for about 10 minutes of Q&A. That said, don't let that stop you from typing questions throughout the webinar. And as we see relevant questions or get opportunities, we will stop mid-discussion. With that, I'm excited to get into this talk with Brady Dibble and Solar Designer. And why don't we kick it off, Brady, with you? If you can give our listeners a bit of a little bit of information on your role here at CIQ and your role with Rocky Linux Hardened.
Absolutely. Brady Dibble. I am product at CIQ. I've been here for about 15 months. I've been working on the Rocky Linux Hardened alongside Solar for a number of months now, alongside our broader Linux engineering platform and our ecosystem products, which assist customers with IT automation and similar activities. And I'm probably the least interesting person here compared to Solar Designer.
And with that, that's a good handoff. Solar, can you tell the audience a bit about your role at CIQ with Rocky Linux from CIQ Hardened or RLC-H, as well as a bit of your background, which is pretty important?
Yeah, thank you, Brian, and thank you, Brady. At CIQ, I co-lead the security team, Linux security team specifically, together with Jason Rodriguez. And essentially, I lead this project, RLC Hardened. As to my background, I've been into computer security and open source and performance optimization relevantly to this project since mid-90s. And I founded OpenWall, which is a community project and a company where we developed hardened Linux distribution, first released in 2000 and maintained for a couple of decades. And now I'm building upon this experience our team at OpenWall had gained and the learnings and what we learned also from community, from users of this distribution. We are building upon all of this to create the Hardened Linux distro project here at CIQ. But we are moving forward. It will not be just reuse of what we had, although we are reusing stuff, obviously. But this is the modern age, as things have changed. And also, the distribution we are building is very different because here we are focusing on creating the unique combination of ABI stability and API, obviously, as well. That is customary for enterprise Linux distros, and we are combining this with fast pace of security hardening enhancements during lifetime of this long-term supported distribution. So to reiterate, it's on one hand, the stability as a stable software versions maintained over multiple years, like it's expected for enterprise Linux distros, and its compatibility with enterprise Linux standards, but it's also rapidly evolving security hardening and
So Solar, so you're stealing my fire. I'm going to pause you there for a minute. So I have some stuff to
sorry,
talk
Brian.
about later.
Yeah,
But thank you for the introduction. And I want to say, I can't ask you to brag about yourself, but I do want to call out to the audience here that you have, for a long time, not only been an expert in Linux security, but a thought leader in Linux security. And as Solar said, he created and founded the Open Wall Linux, a security-focused hardened Linux distribution or Linux project. Within that, developed a number of modules, one that is very well-known, called John the Ripper. He's discovered some major vulnerabilities. He co-created and is a co-maintainer of the Linux Kernel Runtime Guard or LKRG, which we'll talk a bit about more later. So without embarrassing you, Solar, I do want to make sure that the audience understands that you represent the type of deep security expertise that went into Rocky Linux from CIQ Hardened, experience and knowledge, but also you represent the Linux expertise that we have here at CIQ. So I'm going to move on, and then Solar, I'm going to want to get back to the detail that you were getting into shortly. Before I do, Brady, I want to go to you as our product guy and ask you to explain what is RLC and why was it created? Why do we need it?
Absolutely. So Rocky Linux is already great, especially with the end of life of CentOS and all the changes that have been happening in the Linux ecosystem. Many enterprises and customers have naturally landed on Rocky Linux or other EL distros as the kind of spiritual successor and technical successor to CentOS. So Rocky Linux is awesome. We love it. CIQ has been a principal sponsor. The CEO of CIQ, Greg Kurtzer, was one of the core founders of Rocky Linux. So we're deeply entrenched in Rocky Linux itself, and we think it's a great distro that people should be using. Now, that is, at the end of the day, still a community project, and it is a standard enterprise Linux distribution. Its goal is to be flexible, its goal is to be powerful and stable and reliable, and it's great out of the box. Some people, some customers, and especially enterprises need more. So the first thing that CIQ did was we launched Rocky Linux from CIQ. It is Rocky Linux, but we added the commercialization around it, the accountability that you can really only get from having it hosted and delivered by a commercial organization, things like open source indemnification, the ability to communicate with someone directly if you need faster support than just going straight to the community. So there's a lot of commercialization and support around Rocky Linux in RLC that you're already getting. However, it's still off the shelf, general purpose enterprise Linux.
Okay.
What we see in kind of our vision for Linux is we believe the operating system can do so much more. Rather than leaning in towards standardize, and one size fits all, we see that there are many different use cases and workload specific optimizations that our customers absolutely need. They're already taking Rocky Linux and then having to bring it in internally and do a considerable amount of maintenance and modification and optimization, sometimes pulling a lot of open source tools and kind of cram them all together and make them work themselves. And this is something there are tools out there, there's products out there, but not everybody is a deep Linux expert, and not everybody or every enterprise wants to maintain such a complicated amalgamation.
I understand. I'm assuming lots of times, sorry to interrupt, I'll hand it back, is either people aren't experts or they have other important things to do. So if they could save time and possibly the risk with manual hardening, then why not, right? And sorry to interrupt. Back over to you.
Rocky Linux Hardened is our CIQ, looking at all the work we've done for some of our customers and the expertise, the deep security expertise CIQ has internally, and brought our opinion of what hardening looks like. We know that with the threat actors out there today and some of our customers who are constantly under attack, that just a standard hardening you're going to get out of the box is not enough, and that we believe that there is much more that can be done to get out ahead of this standard hardening, standard security, and start actively preventing attacks. And that's where Rocky Linux Hardened came from, is we're saying, hey, here is our opinion of what hardening should look like. And here's something you can effectively turnkey use to start protecting yourself and your interests in production.
Awesome. So Brady, thank you. I'm going to want to go to Solar in a minute, but before I do, for his take on the what and why. But before I do, if we're looking at this from a business level, right, a CISO level or an IT operations management level, what are the expected benefits or gains from deploying Rocky Linux from CIQ Hardened or RLC-H?
So you're making a balance between costs and risk and productivity. You don't want to impact your performance and you don't want to impact your functionality. The OS is there bridging the gap between all the hardware you're invested in and the expensive software stack you've built out. So it has to work. You want to maximize performance. It has to have all the functionality. But in the meantime, it can be very expensive to build and maintain your own hardened operating system. Companies do it. It is a very time intensive and you have to have the right skill sets internally.
Okay.
Even then, you have to maintain it release over release, make sure it's always stable, make sure it's stable upgrades, make sure that you're always keeping par with the industry. And threat actors don't wait around for things to go through bureaucracy before they launch it and start trying
to make sure that you'd wait for you to get all your patches in place.
We'll go through. They're not going through sprint cycles and to get permission to start using the latest cutting edge technology. So it's a cost factor from the perspective of do you want to maintain a team that large? It's a factor of can you get and build a team of the security experts to do it? And it's a factor of mitigating risk. What are you going as far as you feel you need or have to mitigate the risk of the increasing risk of all the cybersecurity threats that are out there?
Awesome. Thank you. And I want to go with that. Solar, do you have, and I'm sure you do, some more to add as to, at a top level, what is RLC-H and why is it important? Why did you guys decide to build it?
Thank you. I liked a lot what Brady said. Everything is just right and very well said. Thank you, Brady. I have a few things to add, only a few because it was so well said. Specifically, in the community Rocky Linux project and RLC Rocky Linux from CIQ, we currently maintain bug compatibility with Red Hat Enterprise Linux. It would take some extreme reason for us to deviate from that. What we are doing with RLC Hardened is we are actually deliberately deviating at least from bug compatibility. So we do fix bugs. And we do make changes for hardening, obviously. And then another topic that was brought up is reasons to use RLC-H, business outcomes. Brady spoke very well, but I can add maybe a slightly different perspective, a bit more technical. What using the system actually means for sysadmin, for example. So our goal of the hardening is that fewer systems would actually get compromised. Those numbers are small anyhow, luckily, or because our upstream, our baseline, Red Hat Enterprise Linux is so good, they do a lot of hardening already, but our upstream and our baseline, so we will always be adding more on top of that. We already have some additions on top of Rocky Linux 9, so on top of Real 9 as well, and we will be having more. So returning to my previous line of thought, fewer systems compromised and lower impact of successful security compromises as well, and a better detection of successful security compromises. And then in certain cases, when a new CVE is revealed, we will be able to find out that our system's the hardened distro is not affected or affected to a lesser extent. We will communicate this to customers, and there will be maybe less of a panic to address those CVEs. They will be addressed, obviously. If anything still needs to be addressed on specific systems, there will be updates, they will be timely, but maybe less of a panic. And then for specific CVEs, we will occasionally patch them ahead of our upstream. So if we identify some CVEs that is important to patch, and that it's low risk to patch. Maybe it can sound paradoxical to some, but fixing a bug always actually carries a risk of breaking something, introducing a new bug, or some unexpected interaction. So when we consider fixing something ahead of our upstream, it's not only about criticality of this particular issue we are fixing, but also potential risks associated with it. So when the balance is good, we will fix issues ahead of our upstream. And one final thought I had is that running hardened systems may be good for, not literally for compliance. This project focuses on real-world security and not compliance. This is an important distinction. But for certain cases like M&A, when security of a company being acquired is evaluated by a potential buyer or for due diligence, then the very fact that all the fleet of servers are running pre-hardened operating systems, it is a plus.
That is awesome. And then so to play, you set me up for a good segue as well. So, I hear rough summary is if you run RLC hardened, you should have fewer systems exposed, smaller attack surface within those systems, better detection, faster remediation, timely updates, sometimes ahead of upstream, and then also what we kind of, I think, in marketing materials called your audit ready. Not necessarily in the terms of compliance, but you are in the cases of M&A, for instance, where people are doing due diligence. DoorDash actually had an issue with this a while ago when, I'm sorry, not DoorDash. I'm forgetting it. The drinking application had an issue with this when they were acquired. So you were saying running pre-hardened or hardened Linux systems should help with that due diligence. Now, I'm going to use this, Brady. It looks like you may have some comments, so I'm going to actually first let me see. Did you have anything to add to that?
Nope. There's a lot of interesting details to get into, but as with respect to time, I think maybe some of them will be covered.
Okay, awesome. So I want to move into a little deeper. You brought up compliance, Solar, and hardening, and I'm out there and I'm trying to learn how to harden my Linux systems. I come across these benchmarks such as STIG and CIS, right? And so I was under the belief that if I just go ensure my system is CIS compliant, I am good. Why is that not sufficient, or why did we not just align with CIS benchmarks for our hardening? What is the difference between rocking Linux from CIQ hardened and applying CIS benchmarks?
This is obviously something we discussed when starting the project, and I would say those things are orthogonal. So what we are making in our hardened product is changes that are pre-baked into the system, and this includes code changes and code additions, extra packages for security. What those hardening guidelines say is how to adjust settings that were meant to be adjusted and some that were not on pre-existing Linux distributions that are not specifically intended as hardened. This doesn't mean there is zero hardening. You cannot find a Linux distro that has no hardening today because some hardening went into ultimate upstream projects. But most distros do not add hardening as the last layer like we are doing here. So those guidelines are about hardening those distros and specific installs of them or maybe there may exist some, I know, some do exist, like on AWS Marketplace, pre-hardened images, but still it's a modification, a fork of the distros for specific install that is poorly maintained as a fork, not maintained at all in those images, where you install, then you update, and then you may have some of those settings lost on other update. You have to reapply. And what we are doing here is a actual product that is pre-hardened with, like I said, primarily with code changes and additions, which also add additional configuration settings that didn't even exist before. And we will be providing documentation on those, but most importantly, we provide reasonable defaults. So a guide is not really necessary to have a system secured for real-world usage. If needed for compliance, then they can be combined, both what pre-hardening we have applied and most security hardening guides can be applied on top of our systems.
Phenomenal. And I think there are plans actually to add CIS compliance to Rocky Linux from CIQ Hardened, but that's in addition into or over and above the other modifications we've made. Is that correct, Brady? And do you have any comments to add?
No comments. I mean, we do intend to provide CIS guides for CIS and STIG, but that is in addition to. The core value is really coming from those code changes that Solar's talked about, where we're going above and beyond what you will get from these STIG or CIS guidelines. The code changes, which are going out and reducing the attack surface, it's adding additional prevention for entire classifications of vulnerabilities, but it's also adding detection, because in the end, you're never going to prevent every single penetration event, but what you can do is greatly increase your ability to detect when those things could happen or almost happened. And that's part of that whole trifecta of reacting to security events by patching when vulnerabilities are detected, outright preventing new vulnerabilities or at least mitigating them until you have time to get those patches applied, and then detection to ensure that when things do penetrate, you know about it or you can catch them very early in the process.
Awesome. Thank you. And for the audience and for you guys, I am going to want to get into the how, right? The details of the hardening and the modules momentarily here. But last sort of set of questions before we do that I'll throw out to both of you is, how is RLC-H more pre-hardened than RHEL and other enterprise distros? And I'm going to add another question. You guys figure out how to parse this. And why don't I just do this myself? Why don't I just go get an upstream distro and go find some guides and do the hardening myself? Anybody can pick up that question.
I'll go ahead and start. Part of it is many of the guides do focus on, I got my STIG or I got my CIS, I'm good to go. And that's not necessarily with code changes, or you're bringing in, even LKRG as an example is an open source project, and many of the items we're bringing in are open source projects. Some of this work has been done as part of the special interest group, the security special interest group at the RESF, the Rocky Linux Enterprise Software Foundation. So some of these things are out there. Integrating them with your system, with your specific setup, ensuring they're maintained, build over build, minor version over minor version, update over update, not even accounting for all the enhancements that we have on the project roadmap. That's already a lot of work to incorporate, to ensure stability, to maintain it, to make sure it's configured correctly. This can be a large lift. Can you do it? Yes, and everything CIQ's work is in the open. So those who are particularly savvy can go and pull some and put it together. However, this is not always feasible for an enterprise from the perspective of, do you have capacity and bandwidth to do that? Do you have the headcount and just time to do it? Does your procurement or your auditors allow that to be exclusively done internally, or do you need some sort of commercial indemnification alongside this security work for risk mitigation purposes? So you may not necessarily be, your business side might necessarily want that to all be in-house. So there's definitely the ability to do it, but there's a lot of value added by having it come from CIQ, both for the convenience and reliability and stability, for the headcount and capacity, and also for the business liability.
Okay, and thank you, Brady. Solar, do you have anything to add, in particular around how is RLC-H pre-hardened different than RHEL and the other hardened enterprise distros?
Yes, so I inadvertently answered part of this question earlier. RHEL is our upstream and our baseline. So we already have all the hardening they have done in the minor release that our RLC-H product is based on. And I have a lot of respect for Red Hat and their engineers for the hardening they do. But just because how we are positioned as a downstream, we inherit all of this and we add more to it. So that is how we are different. We have more hardening. And how this hardening is different from this, I would say it is more progressive. It is evolving at a faster pace. We pay more attention, maybe, or at least we are quicker to adopt new hardening measures, and this is our intent. And when vulnerabilities are found, we review not only the specific bugs, but we also learn from them. We learn the vulnerability class if it's a new class, or if it falls into existing, we treat it as statistics, basically. This vulnerability class is common. And we try and address the entire class. So we add hardening changes more than just code fix to individual bug. We had code changes like defensive programming, I would say, to prevent further bugs like it yet undiscovered or even not introduced yet from having full impact or from being at all.
So that is actually a great statement on the accelerated risk mitigation and the way we enable you to proactively mitigate threats. What I do want to do is dig a little deeper, Solar, into the specific system level hardening. So maybe you can take a moment to cover what some of the key hardened modules are and why you chose them. Or actually, maybe I'll set it up. Maybe we start with the deployment of LKRG. I know that's something that you co-founded and you're a contributor to, that we've chosen to deploy in RLC-H. And by the way, David and Christine, we are seeing your questions. If I don't get to them in the next 5 minutes or so, then we will get to them during questions and answers. But sorry, back over to you, Solar. Can you tell us a bit about what modules and why they were chosen, maybe starting with LKRG?
Thank you, Brian. But if you don't mind, I'd like to address one previous question a bit more fully first, before we have moved on. The question was, why don't you do this yourself, harden the distribution, the system, Rocky Linux or RLC, to create the equivalent of our hardened system? And this is related, obviously, to us doing things in the open, contributing to the Rocky Linux community, publishing everything as open source, which we intend to. So yes, you can take the open source code, even though a lot of effort, many years of effort went into it. For example, for LKRG, which you have mentioned, Brian, the project we released publicly in 2018, before CIQ even started as a company. And it was founded the project by my colleague Adam Zabrodsky. He's currently a director of offensive security at NVIDIA, and this is his pet favorite open source project. Anyway, this is a distraction, sorry. But we do a lot of open source, that's my point. And yes, you can take this open source stuff and build it yourself and create a hardened system, and some sysadmin with advanced skills could do this and would have fun with it. But at enterprise size, it is a fleet of systems, and maintaining each one individually is hardened would be a lot of effort. and installing them from some repository, we would essentially be duplicating the effort we are doing at CIQ in terms of productizing. Yes, you could productize this for your company's internal needs, but it's a lot of effort, really a lot. And one other point that I haven't heard mentioned yet is the secure boot chain. So we have signing of the boot chain components by CIQ, and this includes LKRG. Something you wouldn't easily do yourself unless you introduce your own keys, which you will need to set up on every system in firmware settings, which is cumbersome. Not something you would do at a company, something you may do on as a hobby on your own computer, but not beyond that.
Awesome. Thank you for that answer. And then if we could then move to Solar, what are, and I'll reframe the question, what are the modules that were hardened and why were those chosen? And if you need a starting point, I know there's interest in LKRG, so maybe start with LKRG.
Yeah, so as a project that have already been mentioned, we have LKRG, Linux Kernel Runtime Guard, which validates integrity of the kernel itself and of some of its data structures, specifically pertaining to information on running tasks. It is intended to catch various kinds of unauthorized system changes, such as introduction of rootkits, and in a certain third-party study, there's a master's thesis written on it. LKRG caught 8 out of 9 kernel rootkits tested. No other kernel rootkit detector tool was anywhere close to this result, even though this isn't even primary focus of LKRG. In LKRG, we are thinking higher level about protecting the kernel and its data in general, not specifically against rootkits, but it also does that. And it also detects kernel vulnerability exploits, specifically those that try and modify task credentials, so that you have a non-root shell and an exploit would cause it to gain root privileges. We try and detect this so promptly that those privileges would not be used at all. For example, when there is an attempt to open a file using whatever privileges a task has, LKRG first checks that those privileges are authorized against its shadow database of process credentials that keeps track of what is expected. So an exploit would have a harder time. It would need to target both databases, not only the kernel's normal one, but also LKRG's.
Awesome. And then other modules, all Braze. So I know we have a hardened glibc. Can you tell us a bit about the hardening there? I believe we have custom code, or you've done some of that hardening yourself. Can you tell us a bit more about why the hardening and what hardening was in?
Yes, thank you, Brian. And actually, this is what I would have started with, because LKRG is, while it is very important, it's an add-on. It is an extra package that we provide, that we maintain, that we commit to maintain over multiple years, and that we sign to secure boot, all of which is very important. But it is an add-on. And what's most important is changes to our core system packages. They would be harder to describe individually. There will be a lot of them, as we already have too many to mention now. But yes, we have currently changes to glibc. Currently, I would say they fall into 7 categories to glibc alone. And glibc is a core system package. Almost every other package uses it, so it affects how every system runs essentially. One change that maybe stands out is that we have our glibc and its dynamic linker distrust most of its typical environment variables when it's run over a privilege change context. Privilege change, so when the program runs by someone with different privileges, and the program eventually gains when it is running. Upstream glibc already has some of these, but we take it to a next level, and we review the entire list of environment variables changing from version to version of glibc and make our own decisions on what else we can harden there. I wouldn't go into the rest of the 6 change categories for glibc alone, it would be too much, but yes, currently we have override packages for glibc and for OpenSSH, and this list will be growing a lot.
And then we've added the control framework. What was the thinking behind that? Or can you provide some background on the control framework and the thinking behind bringing that in?
Yeah, control is something I came up with for OpenWall GNU Linux, our project that I have mentioned like 20 years ago. And it is about changing system settings that are normally not officially configurable. It's stuff that, for example, CIS guidelines would advise you to change. So you run chmod commands on some system binaries, and you have a program with permissions on its files that are set differently from the way it's packaged. And then on a system hardened with those guidelines, when you upgrade this package, you lose those permissions. You need to reintroduce. In control, it's different. That on one hand, we add something on top of how stuff is packaged. Permissions, config file settings, the defaults, they remain in certain way packaged, static. But then through the control framework, those settings may be adjusted, and importantly, they will persist over package upgrades. We do this through using RPM triggers. So when a package is upgraded, a piece of code coming from control gets triggered. We call those things control facilities. Different packages may add extra facilities to control. And this piece of code is triggered, and it rate reduces whatever change was prior to package upgrade. So you first, on package upgrade, you automatically triggering dumping of previous states, then the upgrade, and then reintroduction of your new custom state on this system.
Awesome. And before we move on to another topic, so we can get into Q&A, which, by the way, there's some great questions. You guys can't see them. There's some great questions coming through to the audience. Please keep them coming. We will shift to Q&A and open discussion in a few minutes. But Solar and or Brady, of course, Brady, jump in at any time if you have anything to add. I'll direct this towards Solar. You've also done some work around password security, around password policy, as well as hashing. Can you tell us a bit more about what modules those are? And,
yes,
and what we achieved there?
Actually, I'm deeply into password security since mid-90s, and this means both offensive and defensive side of it. Actually, I'm into offensive security for Linux, not only for in terms of passwords, root exploits and stuff, and this is important experience that I need to properly protect systems. But in terms of passwords in particular, we do have 2 pieces of code that I wrote or co-wrote with a co-maintainer or different upstream original outs in RLC-Hardened, and this is password QC, which is the password and passphrase, importantly, policy enforcement tool, which we suggest as a replacement for Red Hat's PW quality library. We have some data from a third party. There's a presentation showing how more efficient, or actually more importantly effective, I would say, password QC is. So it prevents more weak passwords without causing greater user frustration. So this is very important balance, and to frame it that way, because it's a trivial task to ensure no weak passwords. Simply don't allow any password, insist on password length like 30+. We don't do that. Also, you can configure a system to insist on 30+ if you like. Yeah.
Oh, go ahead. If I may interrupt quickly, sorry. And I think you were starting to get to this, so forgive me. How does password QC and its performance, you talked about some of the comparisons, compared to what is shipped in upstream realm for password policy and security?
So for typical default settings, as analyzed by third party, I mentioned password QC detected in this specific test 4 times more weak passwords than PW equality from Red Hat. Those numbers are small, but any small number nevertheless matters. It's an account that may get compromised.
Hundreds of systems, especially, right? That small number really matter.
Yeah. So the difference is 4 times in terms of detection of weak passwords at pretty much the same effect on user experience. Or actually even slightly better user experience with password QC, because there are no unexpected rejections of, for example, generated passwords.
Awesome. And that is very helpful. Brady, I want to go to one last question, then last comments, and we'll ship to Q&A. Brady, I want you to start with this, but Solar, I absolutely want to hear your background. And that is, what is the performance impact? Brady, early on, you talked about the fact that there was always a trade-off, right? We can have the ultimately secure system, but it may be unusable in the real world. Solar, you talked about this addressing real-world security. Underpinning those comments are the consideration of performance. Have we considered performance? And if so, how have we mitigated performance concerns?
And I think that's very important. I'll try to keep it concise. From a functionality standpoint, if you can't use the system, then users are either going to circumvent it in ways that reduce security, or you're just not going to be able to use it. The most secure system, the most truly secure system, is one that doesn't actually function in real life. So we're constantly aware of the balance between functionality and hardening. But there is trade-offs, and there are levels of trade-offs, both in functionality and performance implications. From out of the box, RLC-H targets no performance impacts. We're absolutely measuring the performance impacts for everything we turn on by default. At the same time, we do provide, and will continue to provide, optional increases in security with additional hardened tools, like Hardened Malloc is an example, where with maximum security, you will see a performance increase. And we're always looking at how we can reduce that over time. But in the short term, that will not be by default. So if performance is a higher priority for you immediately, then absolute maximum security, you'll be able to turn those things on if you desire. But from our default out of the box hardening, every single thing we add, we are benchmarking and aiming to not have an impact to your performance, and being cognizant of the functionality impacts of any hardening we add to your end users and your use cases.
Awesome. And then, and again, we're going to get ready to move to Q&A, but Solar, I did jump in as you were commenting on password quality. So I want to give you an opportunity to add any additional insights or information on password policy, not quality, and or the performance discussions that we've had. And then after this, there's some questions waiting for you that I'll ask you.
Yeah, thank you, Brian. I would actually like to make this flow from password security to performance, because those topics are related. And related they are for offline password cracking and defense from it. So I wrote and co-maintain John the Ripper password cracker since mid-90s, and this is a lot about performance optimization, because you are working offline with password hashes and encrypted files. It also supports lots of things by now, so cryptocurrency wallets, for example. But returning to password hashes, this is about optimization for performance. So I have a lot of experience with this, and this is very useful also to minimize performance impact of security hardening changes, to know what will have impact and what will not. Still on the passwords topic, another change we are making in RLC-H is we enable YesScript password hashing as a new default instead of SHA-512 crypts that is used by upstream Enterprise Linux 9. YesScript is something I designed using building on top of the excellent design of S-Script by Colin Percival, who was in one of his many roles FreeBSD security officer for a while. And this S-Script is the next evolution of this concept, sequential memory hard password hashing. It is used already by many other distributions, but not yet by Enterprise Linux. Here we obviously make it enabled by default, and this maintains compatibility with standard Enterprise Linux 9 because all the code is already in there. I contributed to upstreaming it as well, and others did contribute. Obviously, it's open source. So we enable it now, and it does provide advantages against offline password hashing, in particular on GPUs. It is currently unimplemented on GPUs, and that's for good reasons, because GPUs are not expected to provide a lot of performance benefit over CPUs for attacking those hashes. So there is little motivation for people to implement it that way, but they will implement, hopefully, at some point. And I do expect, like I mentioned, a little performance improvement going to GPUs. So we provide this kind of defense. And on performance of the hardening changes. There are two kinds of hardening changes we make. Most of those have no performance impact at all. So those changes to core system packages, like I mentioned, LXC and OpenSSH, right now there's no performance impact. And then there are optional additional components, so maybe at a future point additional configuration settings that will have performance impact. Right now we have two additional packages, the Linux Kernel Runtime Guard and Hardened malloc for the kernel and for user space respectively. It's a protection that has performance cost. Linux Kernel Runtime Guard has low performance cost. According to a set of Pharonix benchmarks, it's about 100 tests. The geometric mean of system slowdown with default settings of LKRG was 2.5%. This is mean, which means that certain tests became a lot slower and some not at all, but the mean is 2.5%. For hardened malloc, unfortunately, the performance impact is a lot higher, it's in tens of percent. But as I mentioned, neither it has to be enabled, so customers can choose whether to enable these things on a particular system. And for example, they may be enabled on a system when there is still idle processing time left, CPU time left on the system to have greater protection. And if the system later starts to experience load issues, those protections can be disabled by the sysadmin in order to gain better performance at expense of security. So the trade-off is left up to the sysadmin.
Right on. Thank you. I'm glad we went back and you expanded on that answer. Thank you, Solar. Brady and Solar, thank you for answering my questions and participating in the discussion we've had thus far. We're running a bit behind my intended schedule, so I want to go ahead and jump over to Q&A. I don't know if you guys are seeing it, but we've had some great questions come through from the audience. So I am just going to jump right in. I'm going to start out with a question from David that asks, is LKRG implemented using eBPF? If not, is it just user mode code?
Thank you for the question. It's neither. It is a kernel module. There are also user mode helper tools, but primary LKRG is a kernel module. So it does not use eBPF. It loads into the kernel's old-fashioned way with native code, no eBPF VM. And it intercepts some kernel functionality through key probes, so optimized to ftrace by typical kernels, actually, in the same way that an eBPF-based implementation would. There actually exists another project that does somewhat similar things through eBPF, but we do it through a kernel model.
Awesome. Thank you. Moving on to the next. Another question from David is, are you using SE Linux in MLS mode?
As to SE Linux, we retain what real uses, so what our upstream enterprise Linux uses. We retain all of it, and we currently make no changes to that. The protections we are adding are orthogonal to those provided by SE Linux. Well, one related thing is that LKRG adds a little bit of protection for SE Linux itself. So if it was enabled and it unexpectedly becomes disabled, LKRG will detect. But other than that, we make no changes to SE Linux currently.
And then Brady, I want maybe to direct this one towards you as I march down the list. Do you bring your code changes back to upstream? And if not, why? And I know there's absolutely a component as being the product owner here that's on you to answer, and then Solar, maybe add any clarification.
Yeah, absolutely. It's our policy that any work done on open source code is done in the open, first of all. So everything that CIQ works on will have an open source or public GitHub repository where anyone can visit. We make this, free and open. Our FIPS work is done in the open. Our LTS work is done in the open. We make it as easy as possible to get access to it. As for contributions upstream, we absolutely do make contributions upstream and push contributions upstream where it makes sense. Not all of them make sense to contribute upstream, but when it is something we feel that the upstream would want or should be part of the upstream package, we do push it. In some cases, it may be pulled from our open source and in the open development.
Awesome, thanks. Anything to add to that, Solar?
Yes, Brady, thank you for the excellent and entirely correct answer. And I can add some specifics not only regarding open sourcing of our work directly, but actual contributions to upstream projects where we actively contribute or at least encourage similar changes being made there. I have mentioned 7 categories of changes to glibc we currently have, and one of those changes, the equivalent of it, recently was implemented in upstream glibc. I helped review those changes. I encouraged this a lot, and I think it wouldn't have happened if I didn't remind about this. In particular for the ASPrint functions, the semantics are finally changed to be safer.
Okay, so let's see. Going on to the next question, is LKRG, specific to LKRG, is it different from IMA? And maybe if you guys are familiar with IMA, which I'm not, you can quickly explain what that is. We can table that one for a minute and go to the next, and then we can go back to Christelle's question if and when we get a chance. Question here, these next 2 questions from Michael and Matthew are really about deployment. So Michael asks, what are the thoughts on RLC-H on embedded devices, as well as use in regulated and compliant environments? And I know those are kind of 2 different things. I know Brady will have some thoughts. But maybe why don't we start with Solar? And I think in particular Solar, how about RLC-H on embedded devices?
It should work where typical Rocky Linux works. We make no changes that should cause extra compatibility issues, so at least we will treat those as bugs and we'll try to fix and avoid. So it's usable. And then the question is which embedded devices and what's the purpose. For example, we hear that for LKRG, independently from this project from Rocky Linux, LKRG is being used on some Android devices by some companies making some derivative. So people are using this, but whether you should, it really depends on your use case and what you want to achieve there. You can have security hardened embedded device, yes, this makes sense.
Okay, and then I think I want to direct the second part of the question to Brady to answer quickly, sure. And that is, what about the use of RLC-H in regulated and compliant environments?
Absolutely. And just toss it out there, embedded in IoT, definitely look at those distinctly. We have heard asks about hardening for IoT and embedded devices, distinct from on-prem, HPC, and cloud use cases. But we also want to respect that there are some nuances with embedded in IoT items that are not necessarily captured in the scope of the RLC roadmap today. We're definitely, we work with a lot of large like on-prem bare metal and cloud-based use cases for RLC hardened, but know that embedded in IoT use case is something we're aware of. For compliant, I want you to know for compliance, for auditing, for going through your ATO, for talking to your compliance team, we have a separate product called Rocky Linux from CIQ Compliant, which is going to be announced in the near future. And that's based a large part around our work we've done with customers around compliant FedRAMP, IL type situations. And it's going to be based around our FIPS 140-3 certified modules and additional compliance-based products that we're packaging all into one individual item. So when you're looking purely at compliance, the RLC compliant will be something that I would ask you to look out for in the very near future. For RLC hardened, compliance is not our first goal. It will, by definition, meet some compliance needs, but we split out RLC hardened from our RLC compliant explicitly because with some of the compliance aspects, you are focused on trying to meet the compliant requirements, not so much trying to purely target the most cutting edge and, as Solar mentioned, progressive threats. There is prevention and there are code changes that you can't necessarily do while staying compliant with certain things like FIPS 140-3. And so we're splitting these into two separate items. Pure progressive cutting edge security through RLC-H and maximum convenient compliance through RLC compliant.
Excellent. Great answer, Brady. And before we go into our last question and get ready to wrap up, I'm just going to report out that one of the questions from Christelle, I believe is how I pronounce it, was, is LKRG different from IMA? Sultan, she came back and explained that IMA is integrity measurement architecture. And Sultan said, yes, LKRG is different from IMA. LKRG isn't an LSM. So with that, we'll go into our last question because we're running out of time. But guys, frankly, your answers were so good and this information was so valuable, I didn't want to stop. I wanted to cover as many questions as possible. So we'll go ahead and go into one last question and then wrap up. This question comes from Matthew Smith, and it is, would the advice be to replace all Rocky Linux servers with RLC-H or use a high-spec RLC-H like a kind of firewall in front of the Rocky Linux estate? Very interesting question about where you deploy this in your overall topology. Curious on the responses.
I'll let Solar go first, but I have
I can take this one. So we intend RLC-H as a general purpose operating system, just like Rocky Linux is. And so we intended for usage on all systems. I understand that in some cases it could be different for various reasons. Not all systems could be switched to RLC-H, but we do recommend switching, and it is most effective this way. It is not a firewall thing, so you cannot easily protect an entire network that way. But one feature that for centralized management that we have is Linux Kernel Runtime Guard remote logging. So you can dedicate a system where you would collect logs about kernel security events from other systems. Currently kernel, but we will probably expand on this. But for this, you need LKRG on all those systems as well. So.
Okay. And then as we're tight for time, Brady, you said you had comment. I'll give you 60 seconds to add to that, and then we'll wrap up.
Not every use case. Again, it's general purpose, but hardened. And then over time, CIQ will be announcing additional workload-specific, optimized product builds. So for HPC, hardened is not necessarily going to be the best use case. For running your AI, hardened might not be the most optimized use case. So there will be additional variants we'll talk about in the near future. where that variant is for use in a case where you would already be using explicitly a hardened build. But to Solar's point, it will run in cases where you would typically run general purpose enterprise Linux. But there are also use cases where the trade-offs from the hardening we do make it not the right fit, because you are having a trade-off from certain functionality or features that are turned on by default. And with hardened, you're intentionally reducing the surface area, which does lead to some unexpected functions no longer being available because those are not typically used.
Awesome. Brady, thank you for that answer. It was great. We are at time. So real quick before I sort of give the audience some next steps, I'd like each of you guys just to take 60 seconds to provide final thoughts. Brady, let's go ahead and start with you. Any final thoughts, closing statements before we move to Solar?
I'd say that this is there has been so much work, and this is the work of decades coming together into a commercialized project, and we're very excited that Solar Designer has brought us along on this journey, and that we're together on this journey. Very excited about putting all of the work that he's done and the community's done in a easy consumable package for all of our customers, and even more excited, however, on how we the rest of this journey, where we're going from here. It's been a long road to get here, and where we go from here, it's just going to accelerate all the things we can do and all the enhancements we can make to hardening by going thinking above and beyond and being very progressively focused on keeping up with the crazy new cybersecurity threats we're seeing in the news every day.
Excellent. Thank you, Brady. Solar, any closing comments? Brief closing comments.
Yeah. I fully agree with what Brady said, and I'd like to reinforce it that it's a multi-year journey, and we are committing to maintaining and improving and building this project over many years. So long-term support for the enterprise Linux distro as usual, plus long-term advances in hardening. This is what we are doing. And another point I'd like to make is that I'm really grateful to my colleagues at CIQ. I'm not doing this alone at all, and a lot of work has gone into this product already by others, and more will be in there. We have really talented engineers here at CIQ, so I'm hoping for a lot more, and I'm really happy to work on this team.
Excellent. Thank you. Well, we heard from Solar and Brady about the launch or the announcement of the tech preview of Rocky Linux from CIQ Hardened, as well as CIQ's view on workload optimized Linux OS distributions to drive business performance. They talked about the system level hardening and modules that were hardened, talked about how RLC-H for short offers accelerated risk mitigation, enables advanced threat detection with hardening additions such as LKRG, and how we make it simple for you to deploy hardened systems, which build on the already fairly secure upstream distros such as RHEL, and then add specific and unique hardening on top of Rocky Linux. If you have more questions, reach out to us at info@ciq.com, or even better, go to ciq.com, products hardened, the link to be posted shortly here, and sign up for our tech preview program. If you'd like to learn how this hardening works and how it might apply to your company, and even more so, even have a voice in the future of hardening of Rocky Linux, then go ahead and just go to the link that will be shared shortly, sign up, and we will look forward to working with you to improve the hardening of enterprise Linux distributions. And I am sorry, I am having trouble pulling the link. I will get it right here. Sorry, I thought I had it prepared. And I will drop this here in the comments section. Oh, there we go. Jess already beat me to it. Thank you. Thank you, Brady. Thank you, Solar, for all the people in CIQ that helped contribute to this release and will be supporting this check preview and general availability. Thank you. And have a great day.